The title of the notes is Choosing a Sample Size. So a lot of times statisticians want to know before they go out in the field and actually start gathering data, how large of a sample size do I need to make this work? And when I say to make this work, I mean we want that small margin of error. We keep talking about margin of error, okay? We want a small margin of error. So if I know what margin of error I'm shooting for, then the question I'm going to be able to answer at the end of the notes today is how large of a sample size should I choose to be within the confounds of that margin of error. So let's start out with a little bit of review. A lot of this was just on your quiz, so I'm going to go through it pretty quickly. In this picture, in words, where would you tell me where the margin of error is? What in the picture is showing the margin of error? The arrows. Yes, error, arrows. Maybe that'll help it stick. So that's the margin of error there on the left. You would get the same exact value for the distance from the middle to the upper end. So that's where the margin of error is. Again, we're shooting for a small one of those. Now, part B, when a confidence interval is given in this form. Here's what my Blue Day kiddos kind of struggled with. And again, I don't think I taught this very well. When you are given a confidence interval in plus-minus form, and that's the form you'll see on your test. So I'm trying to get you comfortable with that. Which of those two numbers is the margin of error? Is it the 0.0137 or the 0.045?
Is it 0.05?
It is the 0.045. So here's really how to read this. Pay really close attention. It's not hard, I promise. Okay, if you didn't know that. What this means is, look at the picture. It means I could take 0.0137, that's the point estimate in the middle, and I could subtract off the margin of error to get my lower end, or I could add the margin of error to get my upper end. So all this is saying is the middle plus or minus the margin of error. So this is the margin of error. And that, then you could write it in the parentheses form with the lower comma, the upper. I've said this several times today. I want it to stick. Do we want the margin of error to be big or small? Small. You can just circle the word small. That's easy. And then putting everything together, when the margin of error is small, the confidence interval is smaller. So the interval itself becomes narrower, gets squeezed towards the middle. And therefore the confidence level, that's the sacrifice you make. If you want a smaller margin of error, then your confidence level also goes down, so that is also smaller. Level, again, is that percentage, like the 90%, 95%, 99%. Okay, that was all review. Today, we are going to be using this formula to figure out what sample size do I need if I'm given a specific margin of error that I have to work with. Something else that you need to highlight in that box that doesn't seem very significant because it's not big, but it is hugely important, is right here. If you do not see in the word problem a specific number to use for p hat, then you will use 0.5. Use 0.5 for p hat unless otherwise stated. In 2 of the 3 examples I'm going to do with you today, you'll get to see that. It won't say anything about p hat, so we'll just use 0.5. In the last example in the notes today, you'll get to see how it's worded, where they really, in a roundabout way, tell you a number to plug in for p hat. So we'll get there. Well, this formula looks kind of crazy, but you should be comfortable with z. Those are on your pink sheet. Okay, we'll just get our z values right off the pink sheet. P hat, I've already told you most of the time you're going to use 0.5. N is the sample size. That's what we do not know, so we'll have to solve for that. There's going to be a lot of algebra today. And then the margin of error, tell yourself right now, hey, that's going to be given in the problem. That's nice. You don't have to guess that or figure it out or calculate it. It will tell you in the problem what the margin of error is. Because the whole point is, if you're given a margin of error, you can find the sample size. Let's look at example 1. Suppose you want to estimate P the true proportion of students at your school who have a tattoo. We can't obviously go ask every single person at the school if they have a tattoo or not. But I want to estimate it with 90% confidence, so that 90% will help me figure out what Z value to use. And a margin of error of no more than 0.07. So I told you they'd give you your margin of error. There it is. That's what we'll plug in for ME. Determine how many students should be surveyed. So if I am bounded to 90% confidence interval and margin of error of 0.07, I can figure out how many students I need to go out and ask, do you have a tattoo or not? So these are the things we need in order to be able to plug into that fancy formula. We need Z, we need P hat, and we need margin of error. N is unknown. That's the whole point of today's notes, is we are figuring out N, which is the sample size. That's what N has always been in the formulas that we've been looking at for the last few months. So N is a sample size, and we don't know that. How many students do I need to ask? All right, look at your pink sheet and help me out. Let's go quickly here. For a 90% confidence interval, what do you plug in for Z? 1.64. In this problem, it does not tell me to use any specific value for P hat, which is the sample proportion, because we didn't sample any students yet. We didn't ask any students yet. There is no P hat to go off of. So that's when you're going to use 0.5 for P hat. If a sample hasn't already been done, then you have to use 0.5. Margin of error, it tells us, is 0.07. So that formula right there in the box, we're going to plug into that. You're going to probably use all of this space, so don't write very big, okay? Because there are a lot of steps. So here we go. We've got Z, which is 1.64, times the square root of a fraction. And the fraction is P hat, 0.5, times 1 minus 0.5. I'm just going to put 0.5. Same thing as 1 minus 0.5. All divided by the sample size N, which we don't know yet. That's why the algebra is going to be involved, is because we're going to have to solve for N. All of that should be less than or equal to the desired margin of error, which in this word problem is 0.07. All right. Some of you have really strong algebra skills, and I know some of you struggle with that, and that's okay. So stay tuned, and I may give you a really cool shortcut, but I'm going to make you do it the hard way first. So over here, if my goal is to get N alone, what is the first thing that I need to get rid of? What needs to go? Well, the square root can't go yet, because on the outside of the square root, it's being multiplied by 1.64. So now tell me what needs to go first. That 1.64 needs to disappear. And if you're like, how do I get rid of it? Always look at what's being done and do the opposite. That's all algebra is. So if I'm multiplying this big square root by 1.64, how do you get rid of multiply? You divide. Make a little note. All we're doing is divide by 1.64, which is the Z value. We're dividing by Z. Well, in algebra, your teacher usually makes you show your steps, and we're going to do it a little bit differently in here. If I divide by 1.64, here's all I need to show. The 1.64 will be gone from the left-hand side, and it will show up on the right-hand side. I'm dividing by it. I hope you're all listening to what I'm about to say. Do not do this. Don't say 0.07 divided by 1.64 and write down like 0.04. Don't put that decimal value here. Why have you been told by all of your teachers in the past in your math and sciences classes not to round in the beginning of a problem? Why would we not want to round that right now? What will happen to your answer at the end if you've been rounding the whole way? It'll be off, right? And if you're on a multiple choice test, you may not find the answer choice you want. So leave it as a fraction until the end. It's actually less work for you. You don't have to pick up a calculator yet, okay? Next. I'm still working on getting this little guy by itself. Now I need to get rid of the square root. What's the opposite of taking the square root? Squaring. So all we're going to do is square both sides. Square both sides. Again, the only way you need to show that work is just, hey, the square root is now gone from the left-hand side. But because what you do to one side, you do to the other, now I need to show that that whole entire fraction is being squared. The parentheses are there so that I know it's not just the 0.07 that's being squared, it's the entire fraction. Again, we still don't need to pick up a calculator. We're almost there. 2 more steps. Here's where people get stumped, okay? I cannot solve for a variable when it's in the bottom of a fraction. You can't solve for a variable that's in the denominator. Can anyone in here tell me how I could get in out of the denominator?
You have to flip it and do something.
A lot of people think flip it, okay, well, but like what math is behind that? Like how do I get rid of the divide by n? Multiply by n, yep. So if you multiplied this side by n, the n's would cancel, right? Tops and bottom cancel. So all we need to show over here is the n is now gone from the left. We would multiply both sides by n. So it's going to show up over here on the right. I'm just going to stick an n next to all of that blob of stuff, showing that it's being multiplied by n. So we divided by z, we squared both sides, we multiplied by n. Last step, we're finally there. N is being multiplied by a blob. How do you get rid of multiply? You divide. So we're going to divide by that blob. We're going to divide by that fraction that's being squared. So here's what we end up with that we can finally put in the calculator. We've got that p hat times 1 minus p hat. And we're actually going to divide that by the margin, the margin of error, which is 0.07, over the z value, 1.64, squared. That will tell you your sample size needs to be larger than or equal to whatever your calculator tells you. Grab your calculator. Make sure you're comfortable typing that in. It should look just like this in the calculator. So get your fraction template, because we got a big old fraction. Alpha, y equals, enter. On the top, we have 0.5 times 0.5. You can use parentheses, you can use times, whatever. On the bottom, we have open parentheses, another fraction. And that's your margin of error, 0.07, divided by your z value, 1.64. Got that off the pink sheet. Close it up. Square it, which is this button right here. And you finally have almost the right answer. So it says 137.2. We're finally allowed to round because we're at the end and I'm out of room on my paper, so I'm just going to do this, okay? 137.2. That will not be an answer choice on your test. You cannot go out and survey 137.2 students at this school. Why not? There is no 0.2. Now listen really closely. Because you've been really good math students your whole life, right? You've always paid attention to your math teachers. You've always been told, hey, round down to 137, because that 0.2 means you round down or keep it the same, right? Well, here's the problem. If I only go out and survey 137 students, I'm just going to be short of what I need. So round up, which feels odd to do. But because this says your sample size needs to be greater than or equal to this, and it certainly can't be equal to 0.2 students, then your sample size needs to be at least 137 students. At least 137. Greater than or equal to that. That means you could go out and you could survey 150 and that'd be fine. But any less than 137 and you're not going to have followed the rules for your 90% confidence and your margin of error. Those are what we were bounded to.
So like for the two choices on that, would there be one that's greater than 137 and the rest would be lower?
Well, for the answer choices, that's a great question. So for the answer choices, you just have to be careful because there might be one that says, oops, you guys, I said one thing and I wrote another. Didn't anybody see that? Sorry, it's 138. Round up. Sorry, sometimes talking and doing math is hard. Round up. So for your answer choices, there will probably be one that says 137, and then 138, and then probably just some nonsense ones in there, okay? That's a good question, though, as far as rounding goes. Rex, there won't be one.
I was just asking that because you had 137.
Oh, okay.
I was like, very confused.
Like if there was an answer choice that said 150, just look at how the problem is worded, and it might say what's the least amount that you need to sample, and the least amount of students that I need is 138. Okay, turn the page. That was a lot of work. Do you agree?
Yeah.
What if we never had to do those steps again? Would that be nice? Okay. Let's look at this problem, and then maybe I'll give you a shortcut. A company has received complaints about its customer service. The managers intend to hire a consultant to carry out a survey of customers. Before contacting the consultant, the company president wants some idea of the sample size that she'll be required to pay for. Everything comes down to money. It's going to cost money to hire this person. It's going to cost them, money. Do I need to survey 100 customers? Do I need to survey 1,000 customers? What am I looking at here? So one value of interest is the proportion of customers who are satisfied with the company's customer service. She decides that she wants to estimate to be within 3 percentage points. That's going to be important in just a second. 3% is 0.03 at a 95% confidence level. The question is, how large of a sample is needed? So the company president can kind of start to figure out, how much is this going to cost me? I'm going to be very consistent. These are the things we need to plug in to the formula, and N is unknown. The word problem says 95% confidence level. Go to your pink sheet and tell me what we're going to plug in for Z. For 95%. 1.96. Cool, that's easy. P hat is always your sample proportion. So like again, if this company had already done this last year and we had something to go off of, then we would plug that in for P hat. But since we don't, use 0.5. That's just the rule. Margin of error for some of you, you might really not know what to put there. And so don't overthink it. This right here, when it says within 3 percentage points, that means 3% either way. Look at the picture. That just means within 3. So 3 this way, 3 this way. So 0.03 is your margin of error. They give that to you right there in kind of a roundabout way. All right, if you don't want to do all of those algebra steps again, then listen. Here's what we ended up with at the very end. We ended up with P hat times 1 minus P hat over the margin of error divided by the Z value squared. So if we know that, maybe we can just jump into plugging into that instead of doing all of that algebra again. This is what is on your pink sheet for your test. So I went ahead and rearranged it in terms of N, since, hey, that's what we're solving for anyway. Let's plug in all the stuff we know over here on the left, grab a calculator, get the answer, and we're done. So P hat times 1 minus P hat over the margin of error divided by the Z value squared. And then always round up. See how fast we are done now? Grab a calculator, figure out how many customers are going to need to be surveyed if she wants to be within 3 percentage points at a 95% confidence interval. Don't do like I did last time and accidentally round down. If you only survey 1,067 customers, you won't quite have met the requirements there. So I'm going to write this, and then I'm going to remind myself to round up. I need at least 1,068 customers in my survey. So maybe now as the company president, I can say, well, that's really not that many. This consultant doesn't have to do a ton of work, so maybe I can afford this. Last one. Example 3, we are only going to do number 1 on example 3. I'm going to help you set it up, and then you'll kind of do it on your own and check your work. So talking about that same company, in the company's prior year survey, 80% of customers surveyed said they were satisfied. So here what we're saying is we have some previous something to go off of. Using this value as a guess for p hat, so it's just telling you use this for p hat because this is what we got last year. Find the sample size needed for a margin of error for at most 3 percentage points with 95% confidence. So everything is the same except what you're going to use for p hat. So we've still got that 95% confidence interval, 1.96 for Z. It's just saying use last year's p hat, 0.8, because we have something to go off of. And then margin of error is still that within 3 percentage points. Third time's a charm. Here we go. We've got p hat, which is not 0.5 anymore, so slow down a little bit if you put 0.5 times 0.5. It won't always be that way. If 80% is on the outside, 20% is on the inside. Margin of error, Z value squared. I'm going to take a second and put this in, and then you do the same, and we'll see what we get. You guys are doing a great job, and we're almost done with this chapter. We just have one more lesson after this. Here's what you should be getting. I don't think any of you would round this the wrong way because, well, just following old rounding rules, you would have to do it the right way anyway. 683 customers, at least 683 customers. I'd like you to write it in words so that you understand you can survey more than that, but because it's going to cost you money to do that, that would be the bare minimum amount of customers you would need. 683. And that is it.